welcome back to Wolfram Tech Conference. I'm Jessie. I'm sitting here with developers and other interesting people using our technology. I'm here with Etienne right now. Can you tell us a little bit about what you do here at Wolfram and sort of what your focus is on?
Yeah, hi. So I'm working on I'm the manager of the machine learning team, and so we're developing machine learning function for the Wolfram Language. That's our main job. And so there's several types of functions. Some are tools for people to build their own machine learning application, such as highly automated tools, just classify, predict. So here the idea is to be able to train a model without much input from the user. Like you define the task, you get the data, and it creates a model automatically. Then we also have more low-level type of tools, such as a neural network framework, where you can play more with the model to do exactly what you want. And then we use these tools to create applications, so machine learning applications that then we put in the system. So example would be, the first one we did almost 3 years ago now was image identify, and we did many more since then. Probably the latest is speech to text.
Mm-hmm.
So that's kind of what we do: create tools and use these tools to create applications in the Wolfram language.
Okay, yeah. So for those of us who were not with me last year, I talked to Etienne at the previous tech conference, and I guess a lot has changed in the machine learning framework in Wolfram language since then. So can you tell me a little bit about what has changed since the last time I spoke with you?
Yeah, so the last time, if I remember well, we just redid the automation for the automatic function. So
we talked about automated data scientists last time.
Exactly. And so we've been continuing in this direction, improving a bit the automation, adding new methods. One new model that we're a bit excited about is we've been automating machine learning with classic algorithms, like random forest or super vector machine or this type of things, but automating it with neural networks is a little bit harder, at least for classic data sets like that are not image or text. But we implemented a self-normalizing network method. That is the first type of neural network method that works well with structured like classic data set. So we're happy with that. Then, in the domain of automatic function, the big new things for version 12 that will hopefully be released soon is the unsupervised learning function. So the main function is learn distribution.
Okay.
Whose goal is to you just give it data. Okay, it's not labeled data. It's just, for example, I don't know. A data set, like a classic data set, and it will try to learn the distribution from this data. And when you have this distribution, you can do many things with it. For example, you can detect anomalies because you will query with the distribution. You will ask what is the probability that you think that this example has, and if this probability is too low, you will figure out something is wrong. It's not this example doesn't follow the statistics of the other examples. Or you can do things like missing imputation, meaning if you have an example and you have missing values, then you can condition your distribution on the known values, and then, for example, sample what could be, so in a sort of simulation of what could be the missing values. Mm-hmm. So this will be in 12, along with anomaly detection and something we call synthesized missing values, which are direct byproduct of having learned distribution. So that was a big thing on the automatic part. And then on the neural network part, there's been a lot of improvement in terms of speed, in terms of new layers. In version 12, there will be a nice attention layer that you can do many more things with it, including transformer networks. There will be, in terms of optimization, a lot of improvement. Like we can use multi-GPU in version 12. It will also take advantage of tensor cores, which are this kind of specialized core in NVIDIA cards that use mixed precision, and now it's going to be in all cards. So that's why we made sure that we can support that and makes your training faster. Then in terms of applications, there's been some new application in natural language processing. So we had a function called text cases that we had a long time ago, and we kind of refreshed it with modern machine learning techniques. And we also did the text contents. So you just get some text and you ask, tell me a bit everything you can find in this text. So, find entities or dates or things like that.
So what do you mean I guess we've had text cases for a long time.
Yes.
The Wolfram language has a lot of pattern matching abilities. So what do you mean that you refreshed it? What did you do to it?
So,
exactly?
okay, so the first version first versions of text cases were mainly using the what do you say, the semantics, the spellings that we created with Wolfram Alpha. So we have a lot of knowledge about, let's say, all the cities, all the countries, all the notable persons, these sort of things. And so we use that to kind of do a classic pattern matching of string matching almost to figure out what's in the text. Now we try to introduce more context. So by using a neural network that we actually really read from the text, like you have a recurrent network that reads from the text and try to infer, let's say, is the string apple the fruit or the company?
Oh, okay.
But so this is a classic task of named entity recognition. But usually named entity recognition deal with 6, 8 type of entities, but in our case we deal with, I guess, almost 200 entities. So we try to have all the entities that we created for Wolfram Alpha and for the Wolfram language to work in text cases. So we created this big data set, and we trained a neural network on that. And it's working pretty well. I mean, it's still a bit experimental, so we didn't experimentalize the function yet. Actually, we have a lot of ideas on how to create a better data set and train something better. So I expect that we'll have a lot of improvement for this function because I believe it's a very important function. I think it's one of the most classic tasks when you have a text to just say, give me all the XXX. Give me all the mention of food, give me all the animals, all the cities, all the whatever.
Oh yeah, that's super common. I mean, people go in their Control F and look for every mention of a word and on a
exactly.
web page.
So this is extension to
to
a type, to something that really understands what's in the text.
Right.
Yeah.
What? Okay, the screen went black here, but what what was on it?
I can start it. This was just actually an explanation of how you could do missing imputation using a learned distribution.
Okay.
So for example, here, it's just a toy example to understand what's going on. So here, all the red points were the training data, and you can see here the fit that learned distribution. Like we could run it. Why not? So let's grab the data. So this is the training data.
Okay.
Okay, and learned distribution. It's probably the most simple automatic function because you really just give the data. It's not annotated, and just learn distribution. And okay, it went a bit fast, but I could show you what's going on. Music information. Okay, this is
that's nice.
Kind of what happened. It does experiments on small data sets, and then increase the size of the experiments in order to figure out what is the best method. And you can see, or you cannot see very well here, but there's various methods. Multinormal distribution has been tested. What are the other one? There seems to be a little problem here. Kernel density estimation, and also some contingency table, and so on. Whatever. Kernel density estimation has been selected. So here is the result. Like we could plot it. Well, yeah, let's plot it. Let's refresh this. And here I was showing an example of synthesizing a missing value. So let's say the value was, or let's say 6.5. The x is 6.5, okay, and y value is missing. So the trick is to condition the distribution on the fact that x is 6.5, which means you kind of cut it here, and the value for y will be the result, will be just this value. So it should be something between 4 and 6. So here we go, and the result is 5.6, 5.5. So you see it's random, which is very useful because then you can have an idea of the possibility for the y value. And I can actually do the histogram. So let's see.
So what is this useful for? Like identifying missing values?
So it's very classic to have missing values in a data set. And sometimes you want to do an analysis of the data that requires that the data has no missing values. So here you would just do synthesize missing values.
Okay.
And it will put probable values, impute probable values in data set. And, you can say, give me a sample or give me the most likely value. That's the two things. And what I wanted to show is if I put 5.5, here you see it will be a bimodal distribution. And so we should see that in the histogram. So this, what you will see here, should be exactly.
Yeah.
So it's the, like if you cut distribution here, if you do a slice here, that's the section in a way. Yep.
Cool. Yeah, I don't have any other questions for you. I guess, do you have anything else that you want to talk about with machine learning functionality in Wolfram Language?
So, I mean, there's always a question of what we'll do next.
Yeah, that's true.
So we've been, in the automation side, we've been kind of pushing the boundary of what we can automate. It was a bit harder to automate how to learn distribution than it was for supervised learning. Supervised learning, it's very, very forgiving. You can just extract features. Algorithms are easy to compare, like two models are easy to compare with each other. You can do the pre-processing you want. You don't have to be very careful. When it's unsupervised learning, for learning distribution, it's a bit more of a problem. Like the pre-processing you do has to be reversible. If you have missing values, you can start mess everything. Sometimes models, it's hard to compare models together because some models, they are very good to generate samples, but not very good to give, let's say, probability distribution. So you have to figure out how to deal with that. But it's kind of it's working out, and so now we feel confident to continue pushing the automation to multi-output predict. So a supervised learning case where you don't just predict one value or one class, but you can predict arbitrary complex outputs. And reinforcement learning. That would be, I think that would be the next. Now we're kind of done on the unsupervised learning part. There's still things we want to do, and we still have to do a little bit on supervised learning, but then we can tackle automating reinforcement learning.
I was saving reinforcement learning questions for another person I'll be interviewing. But can you explain what reinforcement learning is to me? Because I don't know what it is.
Okay, so it's a very different type of learning in the sense that both for supervised and supervised learning, you give a data set, a fixed data set, to the algorithm, to the computer, and they have to learn from that. In reinforcement learning, which I think we could call more active learning, even though in the field active learning has a different meaning, but I think it fits if it's more. You have an environment which is really just a function that you can. An environment that you can act on and get some observation back. So it's a bit the agent that create their own data set by deciding to, let's try this, let's try that, let's interact with the environment and get feedback and learn from that to solve a task. So this is quite different paradigm to supervise and supervise, and very exciting because of all the applications. So you could learn for a robot to learn how to displace themselves, or there's control systems, very classic thing. You want to, I don't know how to pilot the plane, know how to pilot the car.
So we're gonna have reinforcement learning fly all our planes anytime soon?
Well, I think we can already do a completely automatic plane. I think we don't need reinforcement
Like
learning
for
for
air
that.
travel?
Yeah, this I think we do, but
So
I think people would feel unsafe. But I think for planes it's not that hard. For cars it's much harder.
Yeah.
Cars is much harder.
So would you personally get on a plane when you're flying back from the conference on a plane that was not flown by a person?
I would.
You would. Okay. Yeah. I guess the other question I have, I thought of a question maybe for you. With all this automation that we have in the Wolfram language with machine learning functionality, what's kind of the goal that you see? Like, what is this working towards? So we can automate all of these things that were not automated before, but how do you see people using that? And what would you want them to use all this automated features for? Like, who is it for? Like, who is it designed for? And what would they do with all of this automation?
Well, I think machine learning problems are not everywhere, but very frequent for very diverse range of people. Anything, in most, I don't know, let's say most companies, they get the data. I think it's very classic to say, oh, let's try to have an automatic system to tell us, I don't know, how many sales we're going to make, or how many, things we need to buy for our inventory, and I think the step to say, okay, we have some data, we would like to predict this, we would like to, and actually creating a model and putting it in production. That's the thing we're trying to make as simple as possible, and so I think I believe it can be used in many places, and if we make the tool simple enough, then somebody that has no idea about, very little knowledge about machine learning, can just put their data into our system, train something, deploy it to the cloud, put it into production, and it will just work. And then there can be the first step for this person to have a machine learning system running. And then if it actually adds value to whatever their goal is, they can think more and maybe make more elaborate things. So really my goal is to make this first step as easy as possible, so that people don't get discouraged, because it can be a bit frightening. Say, oh, I have to learn statistics, I have to, this seems all complicated, I don't even know what a probability is.
Yeah, and you Google anything about it, and you just get like hundreds, thousands of results that you don't even know where to start.
Yes, and yeah, the number of people going to boot camps and things like that shows a need for such a tool, I believe.
Okay, yeah, no, I totally agree. Well, thanks for talking with me, Etienne, and thanks for watching.
Yep.
I don't know if we're done.